Hello, Honors Algebra 2. We're going to talk about Edgenuity Section 10.2 today, representing data. Data or data, depending on your Star Trek knowledge. We've got two objectives here. One is to describe a data set using measures of central tendency and range. And the second is to determine if a representation of data is misleading. So let's look at some problems here. All right, so we've got some information here. We've got this company FastPaks, a packing company, and a delivery company, and they've got sort of this advertisement, this flyer, okay, a report. It says, we are a delivery company who pride themselves on speed, dependability, and professionalism. And then it lists the number of employees that they have, 12 employees, the average length of service that an employee is there, 12 years, or 4 years, sorry. The average salary of the employees, $39,500, and the employee satisfaction rating, 4 stars, presumably out of 5, but they don't actually say that. So what is the intent of this report? Why would the company put this report out there to the public? Is it to explain the services that they offer, to convince people to ship using their company, or is it to attract potential workers, convince people to work for the company? Well, if you look at this, everything that they talk about has to do with employing people. So it should be fairly obvious that we're trying to attract workers, right? All right, so C is our answer there. I'll give you a moment to look at that, ponder that. And let's move on to our next problem. All right, now let's look at a graph here. Given the graph, which statement is true? We're still talking about FastPaks here, the same company, but this could apply to any company. We're just using approximately the same numbers. So which statement is true? So let's look down at the graph here. We've got a little bar graph, histogram, whatever you want to call it. And we're talking about salaries and how many employees make those salaries, okay? So the largest number of employees make up to $19,000 a year, right? And then we've got a slightly smaller group making $20,000 to $29,000. Then we've got a very small group making $30,000 to $39,000. Then we've got nobody making $40,000 to $49,000, and then somehow we skip all the way to making somewhere between $200,000 and $299,000 a year. Presumably that's like the CEO or the owner or whatever, right? So is this graph drawn correctly? Well, not really, right? Look, we go from 40 to 49 and then skip a whole bunch of stuff. And not only do we go from different measures, we're going from 0 to 19 here, so that's a $19,000 gap, and then we've got a $9,000 and a $9,000 and a $9,000 gap. And then we skip a whole bunch of numbers, and we have a $99,000 gap. So this really is misrepresented data in that way. So the graph drawn correctly? No. Are any titles missing? No. We've got the number of employees here. We've got salary in the thousands here. So the titles aren't missing. The intervals are not the same width. Well, we just talked about that. Certainly that is true. So one answer is certainly C. The graph does not start at 0. Well, that's not true. We do start at 0. So C is our answer, and we're really misrepresenting the data here. Oh, whoops, I went back too far. There, let me redraw that. Oops. Need to be on black. So we're really misrepresenting the data if we're looking at this in any sort of logical way. They're trying to make it look like, well, yeah, we pay more on the bottom of the scale and we pay less at the top of the scale, but really that bottom of the scale should be way thicker, or it should be twice as thick as these two are, and the top of the pay scale over here should be really, really thick, right? So that's all misrepresented. All right, so let me give you a moment to look at that, ponder that. And let's move on to the next problem. There's all this problem of, are we representing the data right, and are we not representing the data right on purpose? So now, which type of graph would be most appropriate for the data? So right off the bat, let me say a couple things. First of all, a pie chart is good for some comparisons, but overall, pie charts are really hard to really glean a lot of good data from. Well, now that we've got like electronic pie charts where you can hover over it and see the actual percentages and maybe even the actual numbers, they're a little bit better, but overall pie charts are a better way of hiding data than they are of representing it. They're good for comparing how large percentages are, but that's about it. A box and whisker plot might tell us some things about this. A stem and leaf plot would give us all the information, but doesn't allow us to compare it very well. The stem and leaf plots are good for compacting the information, but not really for analyzing it. And again, we're just talking about annual salaries. So box and whisker plot might be all right. A histogram might be all right. Which one's better would depend on what you really want to get out of it. So I would say either A or C. I know Edgenuity isn't going to give you that option, but I think it depends on what you're trying to glean out of it. If you're trying to just compare salaries, and you have this list of salaries, well, histogram would probably be pretty good for that. If you're trying to get more out of it, if you're trying to look at like how things really map out, what's the range of things, where is most of the salaries, stuff like that, a box and whisker plot would be at least as good, maybe even a little bit better. It sort of depends. So I would say either A or C. They both have their advantages. Edgenuity has an actual, like, this is the right one, but I think there's some leeway for opinion here, and we have to account for that. Okay? So I'll give you a moment to think about that. And let's move on to our next problem. All right, create and discuss a box and whisker plot for the data. All right, so they give us the information needed, and actually, a box and whisker plot, you don't need the mean, you need the median, you need the minimum, you need the maximum. You don't actually need the mode. And we're actually missing information from this, but we've got that information over here, right? So that's the data that they're talking about. Well, sort of. So the things you need for a box and whisker plot are the minimum, the maximum, what we call the first quartile, the Q1, the median, which is the middle number, which is the second quartile, or Q2, and you need the third quartile, or Q3. The max is actually the fourth quartile, but it's not often talked about that way. And so this is how box and whisker plots go. So you have your minimum right here, and in this case our minimum is 15,000. So you have your minimum that you mark here. You have your maximum. In this case, our maximum is 255,000. And you mark your maximum. And then you mark your median, which is like way over here still at 20,000. That's your median. And then you have a couple more things that you have to mark. You have to mark your Q1, which they don't actually tell us what that is, but let's say our Q1 is right there, and you have to mark your Q2, and let's say our Q2 is right there, and so, oh no, that's a bad, it's a bad mark for the median. Let me redraw. The median is going to be in the middle of Q1 and Q2, right? So more like there. And then the mean could be marked, but usually isn't. And box and whisker plots usually look like that. You might mark the median in there also. So that's a typical box and whisker plot. Again, they didn't give us Q1 and Q2, so I don't know if that is exact or not, but I'm taking my best guess. Okay? So I'll give you a moment to look at that, think about that. And let's move on to our next problem. All right, so here is the actual box and whisker plot. Okay, so this is for that same company. Here's our minimum salary. Here's our maximum salary if we take out the 255,000 salary, the outlier salary. Okay. Here's our first quartile. Here's our median. And here's our third quartile. So that box part of the box and whisker plot is where the majority of everything lies. Okay? So discuss the new box and whisker plot. what are we seeing now? Well, we're seeing that most people are going to make and can expect to make $16,000 to $23,000 a year at this job. We can see that the maximum you can probably realistically expect to make is $32,000. We can see that people on the very low end are making $13,000. And so if you were looking at this one, you might look at it and go, okay, well, this tells me much more realistically what I could expect to earn at this position. Okay, and this is very helpful if you were making a decision to change jobs or take this job versus another job, things like that. This is a good way of looking at it and trying to figure out, is this a job worth taking? You can see what your max earning is going to be. You can see where you're probably going to start. You're probably going to start somewhere in this area here, somewhere, in the 13 to 18,000 range, 13 to 19,000 range, something like that. Keep in mind, the median is the middle number, and most of their employees stay for 4 years, so you probably have to be there a couple of years before you're making 19,000. Okay, so this is a very realistic look at this job. And it's kind of a disappointing look at it, right? I'm not so sure that you jump at this job. If all they told you was, oh yeah, the average worker here makes over $39,000, you'd be like, oh man, that's not too bad. And, I didn't have to go to college for this, presumably, and things like that. And making $39,000 doesn't sound so bad. But when you look at this, it is a much more realistic look at what you're really going to make. And that's really important. And things get misrepresented a lot in jobs because they will include those outlier numbers, what their presidents and CEOs are making a year, to help boost their average. And it's, quite frankly, pretty dishonest. So let's look at our next problem. Okay. Which measure is most appropriate? The mean, the range, the median, or the interquartile range? So we're talking daily temperatures. And so we've got number of days here and the temperatures that we had here. So, like, we had 2 days in the 50 to 54 degree range, 3 days in the 50 to 59, and 3 days in the 60 to 64. We had 18 days in the 65 to 69 range, and then 3 days in the 70 to 74 range. So really, it's not even an option here, but the mode, that is the measurement that occurs most, or the range that occurs most, would probably be the best one. But so what happens if you were to take the mean here, that is the average? Then you get these weird ones that are sort of outliers that are going to change things for you, so probably not the mean, right? The range is just taking the maximum and minimum temperature and subtracting them. That doesn't seem like a good way to represent this data. The median is the middle number. If you wrote every single one of the temperature numbers in a long data set together, and you took the center one, that would be the median, and it seems like a pretty okay way to do it. The interquartile range is the that box in the box and whiskers plot, the Q3 minus Q1 number, which might be okay, but the median is probably better. The way you usually figure these out is you ask yourself, is there a reason that the mean, that the average, doesn't really represent the data? Because otherwise I'm going to use the mean. And if the mean doesn't work, which one tells me a little more, the mode or the median? The other ones you pretty much never use as what they call measures of central tendency. It's almost always just mean, median, mode. And so it's usually, I want to use the mean, I want to use the average. Is there a good reason not to? If there's a good reason not to, which one makes more sense, the median or the mode? The mode being the number that occurs the most, does that make more sense? And the median being the middle number, does that make more sense? And depending on situation, and that's probably why they didn't put the mode in here as a choice, because then it becomes sort of an ambiguous thing. You don't have enough information, you're not informed enough to decide whether the median or the mode is a better choice here. And it might depend on your opinion too. So the mode might be a good choice here as a measure of central tendency, but they don't give it to us as an option to avoid the ambiguity of, oh, I got to make a decision here. So we're going to say the median for this one. So I'm going to let you get a look at that. Now let's move on to the next problem. All right, so now we've got a stem and leaf plot, and again, we're looking for the best measure of central tendency. And again, really, the interquartile range and the range aren't really measures of central tendency. So imagine that you do this. Imagine that I look at it like that. If I want to use, so I've got like a thing that kind of does that, right? If you want to use the mean, one of the keys for using the mean is that that curve should be centered, okay? And if you've got this picture, then using the mean is a good idea. If you don't, which we don't this time, then again you have to ask yourself median or mode. Again, they don't give us mode as an option, so we'll go with median. Okay, so that's why we get that, because in this picture the mean will be somewhere in there, the median is going to be there. And that's where we'd really like to be. Okay? I'll give you a moment to look at that. And let's move on. All right, so now the question is, for which data set is the mean most likely greater than the median? And the way to do that is, let's draw those curves. Draw those curves. So imagine those curves in each situation. And this last one, look at the last one. Look at this last one. That one is really strange, right? There's really nothing that tells us about anything. So that's the first one that we should just throw out, because there is nothing to be gleaned. The other ones, have a little something, okay? Remember, the top of that curve, the top of that, they call it a bell shape, the top of that bell, the top of that curve is the median. And then the mean is in the middle, right? It's the average. So in B, the top of the curve is in the middle. So that line represents both the mean and the median, so they're about the same in that one. In A, so the median is going to be somewhere here, and the mean is going to be here, meaning that the mean is greater than the median, and that's what we want, right? For which data set is the mean most likely greater than the median? So it's probably A, but let's look. Here's the mean. The median should be there. The mean should be less than the median there. So we are going to say it's A for this one. So I hope that makes sense. You can just draw over those curves and it'll really help you see that pretty clearly. I'll give you a moment to look at that. Well, let's move on to our next question. All right, for the data, what is the value of the first quartile? Okay, so how do you get that Q1 value, that first quartile value? First of all, you got to count all of these and find the median. So let's start by find the median. That's the first step in finding Q1, is to find the median. So how many of these do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 of them. I'll just put that there so I don't forget. And so if there's 21 of them, that means there's the one in the middle and then 10 on each side, right? So if I go to the 11th one, I'll find the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 is right there, so the median is 8. And so you actually cut it off there, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's the median. And then you look at all the stuff to the left if you're worried about Q1. If you're worried about Q3, you look at all the stuff to the right. And then you find that middle number. And that middle number, so step 2, find middle of left side. In other words, you're finding the median of that left side, okay? So now we've got, in there, we've got, let me write them again, 3, 5, 5, 6, 6, 6, 7, 7, 8, and 8. Okay, and there's 10 of them, so we've got 5 there and 5 there. So the middle number is actually the average of those two, which, because they're the same number, turns out to be 6. So then we can say that the first quartile value is 6. And that's how you find quartiles. We could have done the same thing for Q3 and looked at the other side, okay? And that's how you start building a box and whisker plot. I'll give you a moment to look at that. And let's move on to what's going to be our last problem, okay? So here we've got a stem and leaf plot showing the number of pages read in a day by each student. According to the data, 75% of students read less then how many pages? Okay, 75%. If I split 100% into 4 parts, it'll be 25%, 50%, 75%, and 100%. And those are your Q1, Q2, Q3, Q4, Q4. And this actually really clearly should demonstrate why we call them quartiles. That is, each one is a quarter of the data, right? This one is your median, so it's halfway through the data, and then these are halfway through the left and right, and then you get to the end, okay? So in order to get this, I have to take this stem and leaf plot and write out all the numbers, find the median, and then find the median to the right of that. So what is my data? Let's see, we got 0, 0, 5, 8, 12, that is 1 in the tens place and 2 in the ones place, 13, 15, 18, 18, and 19. So that takes care of all of these. I hope you can see how I got those. I'm going to have to write small to squeeze all these in here. I've got 22, again, tens place, ones place, 24, 26, 27, 27, 27. I'm not going to make it. We'll just have to keep going here. 33, 35, 36, 42, 44, 46, and 57. So let's count them now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 of them. I suppose I could have gotten that number over here, but either way. So 23 of them, meaning if I put 11 on each side, that would be 22, and then I'd have the middle number. So if I count the first 11, then the 12th one will be my median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my median, my Q2. Okay? Now I'm interested in, am I interested in my Q3 or my Q1? Let's reread the problem. According to the data, 75% of students read less than how many pages? So 75% would be all of this here. So I want to find Q3, but then I want to really think about everything to the left of Q3. Okay? So, and this is, by the way, this is the number of pages read by each student. So now we've got 11 on each side, which would mean 5 on each side, and then 1 in the middle makes 11. So I want to find the 6th one after this. So 1, 2, 3, 4, 5, 6. There's Q3. So, so according to the data, 75% of students read less than, so 75% read less than 35 5 pages. That's what that means. The last 75% is right there. So all the rest of them read less than that. So that's the last 25% there. The other 75% is before that. Okay? I'll give you a moment to look at that. All right. I hope this has been helpful. Thank you for listening.